So this is section 3.2, part B. We're looking at graphing quadratic functions in standard form. All right, so standard form we've already seen before is the form ax squared plus bx plus c. And if it's in standard form instead of vertex form, I don't already know the vertex, but I can calculate it. So the vertex can be calculated by dividing negative b over 2a for the x coordinate. And then to find the y coordinate, you're going to take that and just plug it back into the function. So it's f of whatever negative b over 2a is. Okay, so this is my equation for how to find the vertex if the equation is in standard form. Some notes. If the a value is greater than 0, same thing as within vertex form, the parabola opens up. Oops, and therefore, if it opens up, the vertex is the minimum point. And if the a value is less than 0, the parabola opens down, and therefore the vertex is the maximum point. Right? So if it opens down, it's going to have a highest point. If it opens up, it's going to have a lowest point. Okay, so we've got a few examples here to look at. The first one is going to be f of x equals negative x squared minus 6x minus 4. So the a value is negative 1, the coefficient of x squared. The b value is negative 6, the c value is negative 4. So we want to find the vertex by hand. So the first thing to do is x equals x coordinate negative b over 2a. So negative b is negative 6, so it's negative 6 over 2 times a, which is negative 1. That's going to give us 6 over negative 2, or negative 3. Once you have found the x value, just plug it back into the function to find the y value. So f of negative 3 is negative 3 squared minus 6 times negative 3 minus 4. So negative 3 squared is not 9. That's going to be negative 9. There's 3 negatives there, right? 1, 2, 3 from the square, so negative 9. 2 negatives are going to make this positive 18 minus 4. So that would be 9, negative 9 plus 18 is 9, and then minus 4 is going to be 5. So the vertex is going to have an x value of negative 3 and a y value of 5. So that's my vertex. Does the parabola open up or down? Explain. Does it have a max or a min? Explain. Same thing. So it's going to have, well, it opens down, right? Because the a value is less than 0, so it opens down, which means it's going to have a maximum. So that my explanation deals with the fact that the a value is less than 0. So therefore it has a maximum. That's my explanation. So next page, we've got another parabola to look at. Here, the a value is negative 1/2, the b value is 4, the c value is negative 1. Find the vertex by hand. So first of all, the x coordinate is negative b, so negative 4 over 2 times a, which is negative 1/2. So I'm going to have negative 4 over negative 1, right? Because 2 times a half is 1, and then just a negative. So my x value is 4. So then I want f of 4 to find the y coordinate. So I've got negative 1/2 times 4 squared plus 4 times 4 minus 10. So that would be, okay, 4 squared is 16, half of 16, that's 8, so it's negative 8. Plus 4 times 4 is 16 minus 10. So far I've got negative 8 plus 16 is 8, minus 10 is negative 2. Negative 2. So my vertex appears to be at 4, comma, negative 2. Is it a max or a min? So here my a value, once again, is less than 0. So that means it opens downwards, which is once again a max. Because the a value is negative 1/2, right? So it's less than 0. Okay, so place the vertex in the middle of your table. So my vertex I've already identified as 4, negative 2, and then plot a couple points on either side. So a couple points with smaller x values, so we'll go 3, 2, 1. Larger x values, we'll choose 5, 6, 7. It's always important to know where your vertex is because you don't want to have all the points on one side of it and not be able to see both sides. You always want to have your vertex in the middle of your graph. Okay, so calculator, I'm just going to plug these into the equation. So it's negative 1/2 times the x value 1 squared plus 4 times the, the x value 1, and then our minus 10. So when I plug in 1, I get negative, hold on, I think that looks good. So if I plug in -1, I get -6.5. If I plug in 2, I get -4. If I plug in 3, oops, I forgot to plug it in both places, my bad. If I plug in 3, I get -2.5. Now, so you don't have to watch me fill out the rest of them. I know that by symmetry, I'm going to get the same thing. So I'm going to get -2.5 for 5, -4 for 6, and -6.5 for 7. Okay, so I'm going to graph some of these. At 1, I'm at -6.5, so 4, 5, 6.5. Okay, at 2, I'm at -4. At 3, I'm at -2.5, 1, 2.5, and at 4, we're at -2. Graph a couple on the other side as well. So by symmetry, I can just graph these real quickly here. And I can see several points in my parabola. Now, I really don't actually have enough right here. I'm going to go do a couple more to get a little bit further away. And I'm going to do them by symmetry. So I'm going to do 8 and 10 also. So if I have an x value of 8 or 10, I just want to get a few more since this graph is so long right here. So let me plug in an x value of 8. Gives me -10 for y. And if I choose an x value of 10, it gives me -20. Perfect. So I would have 8, -10. So it's 12, yep, 11, 10, that's 10. And I would have 10, -20. Okay. By symmetry, I also know that I should be at -10 here and -20 here. Okay, I could have probably saved myself a little bit of time with this graph had I considered the fact that because the a value was 1/2 as a coefficient, I may have skipped the odds and just done the evens, right? So if I had done just the evens, I would have been able to get whole numbers to begin with, and I would have been able to graph those. And again, that's just because I need to divide by 2 from that coefficient of 1/2. Okay, so it might be a good idea in the future just to think of your coefficients before you start picking your x values. All right, regardless, our domain is going to always be -infinity to infinity. And our range, I knew that to begin with because I knew the vertex, but I know that it was facing down, so I start at -infinity and I go up to my vertex as my highest point, -2, bracket around that vertex value, parenthesis around the infinity. So there's my graph. It's important to always choose the vertex as your center, like I said before, so that you get points on both sides so that you can get the graph. Otherwise, if you only had one side, you would have no idea where the rest of it should go. But once I have both sides, I can use symmetry to get some additional points. All right, the last question for this section. I've got a scattergram right here, and I want to just discuss, is it better to use linear or quadratic to model it? So it's not perfect because you can see that this point right here is a little bit too low, but in general, there's going to be some sort of quadratic trend to this because you can see that the data is first decreasing and then increasing, even though it's not increasing by the same amount. Okay, that's my reasoning for quadratic. Another way to say that is the data changes direction, changes from increasing to decreasing. So the explanation is that the data changes direction. In our case, it changes from decreasing 92, 84, 73 to eventually 66. In general, from 96 to 85 was increasing. Not that every single point consecutively increased, but the pattern increased. Okay, now I want to use quadratic regression to write the equations. I've got to get my data into my calculator. Got some previous data in here to clear out. Okay, so years, I probably want years since 2000. Yep, up here it says years since 2000, up here at the very top. So we're going to do 0, 1, 2, 3, 4, 5, 6, and 7 for my first column. And then I've got to enter the rest of the data. So 92.3, 84.1, 73.5. So hopefully you can get all your data entered, and I always like to graph it just to make sure that my graph does in fact look like the data. Either my window is going to be different, but it does look like it's going to be correct. If I want to get the same window, I can manually change my window to match theirs. I can see a minimum on X is 0, maximum on X is 8. And I can see a minimum on Y is also 0, maximum on Y is 120. So if I choose the same window, it should look very, very similar to the data I see. So good news. It just helps me verify that I typed everything correctly before I do my regression. To do my regression, I'm back into the stat menu, over to calculate, and quadratic regression, so I'm choosing option 5. Down, down, down to calculate, and I've got my A, B, and C values. My A value is about 2.143. My B value is negative 15.039, and my C value is 93.613. So my model is going to be f of t, or W for wildfires, equals f of t equals 2.143 t squared minus 15.039 t plus, it was 93.613. Okay. Now, find the vertex of the model by hand. What does it mean? Verify by using my calculator. All right, so my vertex. My vertex is going to be at t, because I don't have an x here, I have a t, equals negative b, so negative 15.039 over 2a, so 2 times 2.143. The double negatives make that positive, so I just need to calculate 15.039 divided by the 2 times, so I'm going to do that in parentheses, 2 times 2.143, close parentheses. Okay. So I got a value of 3.5088, so 09. Okay. Then I want to plug that back into the function, so I want f of 3.509. Okay. That's going to give me 2.143 times, I'll just do second and negative. If I hit second and the negative key, it's the A and S, so I can just use the entire value, squared, close parentheses, minus 15.039 times, parentheses, second negative to get the A and S back up there. I don't have to type that way, plus the 93.613. So even if you type that value, you should still get something close to the 67.228. 67.228. Perfect. Explain what it means. I'm also going to verify my calculator. So this is the ordered pair. This is the first, the year value. So this year value would be 2003, right? Because you're adding from the starting year 2000. So it would be in 2003. And I need to know if this is the lowest or highest. You can see from the graph that it's going to be lowest. You can also see that this graph faces upward because of the positive A coefficient, therefore you have a minimum. So the minimum number of wildfires occurred. The minimum number of wildfires occurred at a minimum of 67.228 thousand fires. Alright. The last thing we want to do is just verify on the calculator. So I'm going to take my regression equation back into StatCalc, option 5 for quadratic regression. Remember that you can store the regression equation. To store it, I'm going to hit alpha, then trace to select the y value where I want to store it. I'm just going to store it in y1, so I'm going to pick 1. And then I'm going to calculate. Nothing happens differently in this process. It's the same values for A, B, and C, but the equation's already in here in Y1. If you didn't remember how to get that in Y1, you already had the equation. You could just type it yourself into Y1. Okay? So I'm going to let it graph. And then we're going to find the minimum on the calculator. So to find the minimum on the calculator, once the graph finishes, you're going to hit second and calculate minimum. So that's option 3. And then the questions are left bound and right bound, so you need to go far enough left that you are sure that you're on the left side of that minimum, so you are increasing already, And then make sure, once you hit enter, when you go to the right bound, that you are way past the minimum, that you're on the right side of it somewhere. So you know that you've passed it, and the right side and the minimum must be between those two vertical lines that show up there. And then you just go somewhere in the middle to hit enter for your guess. So the minimum that shows up, mine says on the calculator, 3.508. That's what I also got. It's 3.508. It says on mine 0.5. This one I said 0.9 instead of 0.8, but remember I had rounded those coefficients, so that made a little bit of effect. And then I got 67.234, and here I had 67.228, and again, that's because I calculated that from a rounded version of the model. But very close, 3.5 and 67.2. Comparable to right there. So I'm just going to make my little sketch and write down my minimum. So my minimum here was, from the calculator, 3.508, comma 67.234. Okay. Now, had I typed the model and typed those rounded values, I would have gotten exactly the same two values right here. But because I used the more accurate model by storing the actual equation without the rounded values, I got a little bit of a better answer for this right here. So I always want to compare and be able to check your answer.